In this tutorial today, we're going to take a look at how to convert percent composition data into an empirical formula. And previously, you've watched a tutorial on what an empirical formula is and what it means. And so let's see if we can take a look at the calculation side of things today. I lay it out in 4 relatively easy steps, and so you want to take the percent data and assume you have 100 grams, and then determine the number of moles of each element that is present. And then you're really trying to find a ratio between the elements that are present. And so you're going to use the number of moles that you calculate to help you set up that ratio, and I'll explain that a little bit more clearly in the example. And then you want to find the lowest whole number ratio. So the ratio that you find from step 3 needs to be a whole number, and so you're going to multiply it by an appropriate factor in order to determine your empirical formula. I'll draw your attention over to this text box over here that lays out an empirical formula rhyme. And this is a rhyme really to help you remember the 4 steps we just discussed. In the first step, you're converting your percent data to mass. And so it goes percent to mass, and then mass to mole. Divide by small, and multiply till whole. Because once you convert your percent to mass, you need that mass data to be in moles so that you can work with it. You're then going to divide by the smallest number of moles, so you're going to divide all of the number of moles by the smallest number of moles to find your ratio. And then multiply till whole just means that you're going to multiply by some factor such that all of the numbers in your ratio are whole numbers. So in our example here, we have a substance that is 35.9% aluminum and 64.1% sulfur, and we want to find the empirical formula. And so the very first step is percent to mass. And so in order to do that, we are going to assume that we have 100 grams of compound. We're doing this because if we assume 100 grams, that means that we can take the percent values and turn them directly into mass values. So the aluminum, or the compound, was 35.9% aluminum. So if we have 100 grams of that compound, we have 35.9 grams of aluminum. And the same thing for sulfur. Second step is mass to moles. And so now we're going to take the mass values we just calculated up above, and we are going to determine the number of moles that we have for each one of our elements. And so we use unit analysis to quickly set up a calculation to find the number of moles for each of the elements involved. And then in step 3, when we find the ratio, we are going to take our number of moles and we're going to divide by small. And what that means is we're going to divide by the smallest number of moles, which in this case is the number of moles of aluminum. And so we'll divide all of the number of moles by the number of moles of aluminum because it is the smallest value. And we see here, in doing that, we get a 1 to 1.5 ratio. But we know that those subscripts in any empirical formula and any chemical formula need to be whole numbers. And so we need to, in the final step, multiply till whole. And the simplest way to achieve the smallest possible whole number ratio is to multiply all of the subscripts by 2. And so we end up with the 1 times the 2 and the 1.5 times the 2, which gives us Al2S3. And so the empirical formula that has the given percent composition data is Al2S3. Like we always do, we want to think, is this a reasonable answer? And so we know that since we have a metal and a non-metal, that we're going to have an ionic compound forming. And we know that aluminum tends to form ions with a charge of 3+, and sulfur tends to form ions with a charge of 2-, so that if we cross over those charges, or we to come up with the chemical formula, we would get Al2S3, which agrees with the formula that we calculated using the information given, and so it makes sense. So if you follow those 4 steps outlined at the start of the video, and in particular keep that rhyme in mind, you will have a set of steps that you can follow in order to change percent composition data into an empirical formula. And in the next tutorial, we will see how to take the empirical formula and use the given information to determine a molecular formula.